Hello everyone, now we are going to solve the next question of GATE 2016. This looks like a tough question, but it is not a tough question, it is a simple question. Just need to understand what is the concept working behind this. A solid disk with a radius A is connected to a spring at a point D above the center of disk. The other end of the spring is fixed to the vertical wall. The disk is free to roll without slipping on the ground. The mass of the disk is m and the spring constant is k. The polar moment of inertia of the disk about its center is ma square by 2. We need to calculate the natural frequency of the system. We are going to apply the torque method because it is working. So this is the torque method we are going to apply. In the torque method, if you write down the equations correctly, then the questions is solved. Okay, there is no complicated in the questions. So see here, let us assume that we are going to give some angular displacement, a small angular displacement of this disk like that. Okay, so it would be like that. Theta is the small angular displacement we have provided to this disk. So if theta is in that direction, we know that torque, inertial torque would be in opposite to that of it. So that would be I theta double dot. And if I'm talking about the spring torque would be like that in the direction, that is k. You can see this is the distance a plus d, because a is the radius and d is the distance from the center and the hinge point. So this is a plus d theta. This is the deflection in the spring. You can see this is the deflection in the spring. Okay, and multiplied torque, we are going to consider torque about point of contact. Let us consider C as a point of contact. So multiply with a plus d. Okay, so we just have to make the equations I theta double dot plus k a plus d whole square theta. Now we have to calculate the moment of inertia about point of contact. So it would be Ig plus m multiply this distance. This would be the distance is considered as a. Okay, ma square, and Ig is what? Ma square by 2 is already given. Ma square by 2 plus ma square, so it would become 3 by 2 ma square. So you just have to rearrange this equation. So equations becomes I theta double dot plus ka plus d whole square upon I. Okay, and we know that this term is denoted as the omega n square. Okay, so that means omega n square would be equal to, omega n square is equal to ka plus d whole square upon I. And what is I? 3 by 2 ma square. 3 by 2 means 3 by 2 m a square. So omega n would be equal to under root of 2k a plus d whole square upon 3 ma square. So according to the option, which one is correct? Option A would be the correct answer. Okay, this option would be the correct answer. So it is easy to find out the natural frequency by applying the torque method. We just have to write down the equations accurately, then you'll get the final answer. So I hope you will understand the solution of that question. Thank you.